Alright guys, so this video is for section 2.1, that is modeling with expressions. So we're going to be talking about writing equations in a given context. So we're going to start working with word problems here. So the essential question is, how do you interpret algebraic expressions in terms of their context? So what do these expressions mean and what are they representing in real life? So we've got three vocab today. They're pretty simple vocab. We've got an expression, so any phrase that combines operations, that's addition, subtraction, multiplication, division, numbers, and or variables together, that makes an expression. Our terms, actually, so let's just stick with expression. Let's go ahead and write one out. So we're going to work with one at first. We're going to work with 3x squared minus 2xy plus 6x minus 4. So this is combining operation, subtraction, and addition, numbers, there's some numbers and some variables in here, x and y. It's combining them all. So if we look at our terms, they're parts of an expression that are being added. Okay, so parts of an expression that are being added. And we're going to go ahead and underline them in this case, underline them in red. Well, if we look at this here, we've got some addition and we've got some subtraction. Okay, well, we just want addition, right? This is only talking about the parts that are being added. We only want addition here. So what I'm going to do is I'm going to rewrite this so that we only have addition. So it's going to be 3x squared. And instead of subtraction, I'm going to do plus, and then I'm just going to have a negative 2xy. Okay, because we only want addition here. We only want it being added. Plus 6x. And then plus a negative 4. Okay, so let's look at what parts are there that are being added. All right, we've got 3x squared. That's one term. Negative 2xy. That's two terms. 6x. That's three terms. And a negative 4. That's four terms. So if I go ahead and write out here the terms, okay, if I write them out, it's going to be 3x squared, negative 2xy, 6x, and negative 4. So this expression has four terms. Okay, coefficients. If we look at coefficients, we will go ahead and circle these coefficients in purple. They are the numerical factors of a variable term. So that we're looking for numbers, numerical numbers, okay? So we are not looking for variables here. The numbers attached to the variable. So let's go ahead and look here. We'll look at this first term, 3x squared. We're looking for the number attached to the variable, okay? So 3, that's our first coefficient. Now let's look at the next one. We're looking for a number attached to a variable. Right, we've got our negative 2. Okay, if we look at this next one, we're looking for the number attached to the variable, that's 6. And then this last one, you're like, okay, negative 4. But if you look, there's actually no variable here. There's no variable in this last term, so there's no coefficient there. That does not count as a coefficient. So there's only 3 coefficients. So if we list those out, our coefficients, we got 3 from the 3x squared, right? Negative 2 from the negative 2xy, 6 from the 6x, and no negative 4 because it's not attached to a variable. Okay, so that's as simple as our vocab is. Now I want you guys to work out an example problem on your own. So all of this so far should be on the right-hand side of your journal. Everything so far on the right-hand side. Now I'm going to ask you to do this next problem on the left-hand side. So I'm going to give you an expression, 16z cubed minus 10x squared. Notice I've got different variables in there, plus 4y minus 13. I'm going to ask you to do the exact same thing we did here. So you are identifying the terms and coefficients. So the terms and the coefficients. Perfect. Okay, so when you complete this, you want to pause the video and complete this on the left-hand side of your notebook. On the left-hand side. All right. If you are back with me, I'm assuming that you've already identified these terms and coefficients. And we are going to actually move away from terms and coefficients now. I'm going to erase the vocab. I'm going to erase our practice problems. So if you still need that, go ahead and pause the video. Otherwise, we are going to continue on. Okay, so the next thing we're getting into is starting to look at our word problems. Starting to look at what is happening in word problems and how do we make expressions out of these word problems. So right here I have our first example problem we're going to work with. It says the price of a sandwich, so think about going to a deli, you're walking in, you're going to purchase some things. The price of a sandwich is $1.50. Really cheap sandwich. So $1.50 more than the price of a smoothie, which is D dollars. What does the expression D plus 1.5 represent? All right, so we're going to tackle this. There's a couple things we got to do. So we've got some numbers here. We've got $1.50 more than the price of a smoothie. We've got a variable here that we've got to deal with. And we've got an expression too. Like, what is this expression that we have? Okay, so we've got some stuff we got to deal with here. But in order to start working out these word problems, there's a chart in our workbook that we're going to use. It's going to help us out a lot. So this chart is on page 48. So we're going to go get your workbook. We're going to cut out the chart on page 48, right at the top. And we're going to paste it in the right-hand side of your notebook. So if you need to pause the video, go ahead and pause the video. Grab your workbook, get the chart off of page 48, and paste it in your notebook on the right-hand side. Not on the left-hand side, on the right-hand side. Awesome. So pause the video, get that done. Okay. If you're back, I'm assuming that you've gotten this chart from page 48. It's pasted in the right-hand side. And we're going to start looking back into this word problem. So we're going to look at this word more, figure out what that more is talking about. So if we go into our chart, it shows us for addition, subtraction, multiplication, and division, what kind of words do we see in a word problem? And you'll see that the more is written under the addition column. So that's representing addition, okay? More than the price of a smoothie, which is D dollars. All right, so let's think about our variable D. What does D really represent? The price of a sandwich is $1.50 more than the price of a smoothie, which is D dollars. Okay, so D is the cost of a smoothie. Okay, so cost of a smoothie. All right. So let's think about the cost of a sandwich. A sandwich is $1.50 more being addition. Okay. So D plus 1.5. So this is the cost of the smoothie. So we determined right above the cost of the smoothie plus 1.5. So a lot of people are like, well, that 1.5 doesn't match up with that 150. Actually, it does. Anytime you have a trailing zero after a decimal, you do not have to include it. So this is the exact same thing if I put the zero there or if I don't put the zero there. It's the exact same thing. So the cost of the smoothie plus 150, well, that's just the price of a sandwich. So this represents the cost of a sandwich, which is the other thing that you bought when you went into the deli. So let's think about an example. If, let's say, your smoothie was, let's see, let me erase a little bit. Let's say, if your smoothie, so if smoothie is $5, how much is the sandwich? How much is the sandwich? Okay, so if it's $5 for a smoothie, well, that just represents my D, right? That's equal to my variable D. So we're going to take that $5, plug it in right here, and we get 5 plus 1.5, or 5 plus 150. Well, the sandwich is just going to be $6.50, which matches up with our original problem that said the sandwich is $1.50 more than the smoothie. Awesome. Okay, erasing this. If you still need it, just pause the video. But I'm going to go ahead and erase this. We're going to move on to our next example. Our very last example for this section. Alright, so this one, it says she, who will be unnamed, buys, so purchases C. I don't know if you guys can see that C there. C cucumbers at 99 cents each, and A, there's another variable, A apples at 79 cents each. It says write an expression for the total cost. Okay, so you're going to the store, you're buying cucumbers and apples, it's asking for the total cost. Okay, first thing we got to define our variables. So we're going to say, okay, we're going to let C be, it already put the variables here, so what is C really? C cucumbers. Okay, so it's the number of cucumbers, so how many cucumbers we bought. Alright, our other variable is A, so A is going to be very similar, but we're letting A be the number of apples, right? And we've got the cost of each of those. Cost is 99 cents and 79 cents. Okay, so these are always going to be, when we're talking about purchasing, the cost is always going to be the coefficients. So cost is equal to our coefficients. So if we bought one cucumber, it'd be 99 cents. If we bought 2 cucumbers, it would be $1.98. If we bought 3 cucumbers, it'd be $2.97, and so on. So let's think about what is our expression if we buy C cucumbers and A apples. Well, every time we buy a cucumber, we are paying 99 cents for it. Okay? So 99 cents for the cucumbers. That's the cost of however many cucumbers we have. We're multiplying. Alright, and we're paying 79 cents for each of the apples that we buy. That's what our problem told us. And now what are we doing with those two costs? So you think you go to the store, you buy cucumbers, and you buy apples, you purchase them together, we're just adding, right? So if your cucumbers are $1.98 and your apples are 79 cents, you're going to add them together to get your total. So this expression is going to be the expression for this problem. But what I really want you guys to notice is that this 99 and this 79 are the costs of the items, but they are represented in the expression as the coefficients, right? Are the coefficients of these variables. Okay, so that was really modeling with expressions kind of in a breeze pretty quick. We're going to do a lot more with word problems in the next section. This was just introducing us to starting to work with word problems, breaking them down, pulling things out.